5.3 Image formation of lenses. Construction rules. To explain construction rules, let me show you this simulation. You can see there are parallel light rays striking the lens, and these light rays will then converge to a single point called focus. And that is to say, a light ray parallel to the principal axis will then refract and pass through a focus. On the other hand, when a light ray passes through a focus, then it will then be refracted parallel to the principal axis. And I may make things clearer by showing you this. The light ray that is parallel to the principal axis will be reflected and pass through the focus on the other side. On the other hand, when a light ray passes through the focus, then it will be refracted parallel to the principal axis. Lastly, what about if the light ray strikes the very middle of the lens? It will just go straight. It doesn't matter where the ray box is. It always goes straight if the light ray passes through the center of the lens. Well, some of you may ask, what about the other light rays that strike in different directions? And my answer is, it's difficult to tell at that time. So, all you have to remember is the three light rays, one passing through the center of the lens, another parallel to the principal axis, that it will pass through the focus on the other side, and the last one that pass through the focus will be refracted in the parallel direction with the principal axis. And for other light rays, you will know after the next lesson. The situation for concave lens is similar. You can see there are two parallel light rays parallel to the principal axis. They are diverged after passing through a concave lens. If you project it backward, then you can see the dotted line intersect at a point which is called focus again. What about if it is a single light ray? For the single light ray that passes to the very center of the lens, it will go straight. And if the light ray parallel to the principal axis strike a concave lens, it will be refracted to the direction so that it seems like the light ray comes from the focus. The last one is, when the light ray tries to strike the focus on the other side, just like this. It wants to strike the focus on the right hand side. Then when the light ray strike the lens, it will be refracted parallel to the principal axis. And in this way, we explain how these construction rules are found. The construction rules are important because they help us to find image. Let me show you some examples. This is the case for convex lens, and you can see here's the object. You may move it to the back or closer to the lens as you like. To find the image, we draw two of the construction rules. This is one, this is two. Then you can find the image on the other side. And of course, you may also draw this as well. The three light rays will intersect at the same point, and this point is the image of the tip of the object. And for the whole image, it looks inverted. What happens if the object is closer and closer to the lens? Let's see. 1, 2, and 3 if you like. See that the image becomes bigger. Let's do that one more time. Closer and closer and even closer. And now it is within one focal length from the lens. And now let me draw this and that. Oops. And you can see. Alright. In that way, then the image becomes erect and magnified. Very big. And that explains the table of section 5.4. Nature of image formed by convex lens and concave lens. Let's start with convex lens. When the object is very far away, the two light rays from the tip of the object are almost parallel, and they will converge to the single point just below the focus, in that way producing a inverted image, which is diminished. When the object is closer, you can draw ray diagrams easily, and you can see the image is still inverted and diminished. When the object is even closer and closer, then the image becomes bigger and bigger, and they are further away. You can see the image is now further away from the lens in these pictures. And what about if the object is even closer? When the object is at focus, then the two refracted light rays are parallel, and we say that the image formed at infinity. However, when the object is even closer, shorter than one focal length from the lens, then the two reflected rays diverges, so that there is an image formed behind the lens. This is a erect, virtual, and magnified image, as in magnifying glass. A convex lens gives different images depending on different objects' distances. But for concave lens, it will be easier. Let's take a look. The three light rays are: one passing through the center of the lens, another parallel to the principal axis, then it will be refracted this way, away from the principal axis, so that it looks like that it comes from the focus. There is already the image. Let me draw one more construction rule, which is the second one. This, the purple light ray, aims at the focus on the other side, but then it is refracted this way, parallel to the principal axis. And these three refracted light rays, they all looks like comes from this point, and we call this the image. And in fact, the image is quite small compared with the object, and we say the image is a diminished image. It is also a erect and virtual image. We will then go through some of the pictures on the next pages. So at that time, what I want you to do is label the ray diagrams here. Number 1, 2, 3, 4, 5, 6. And that's that. This is the first one. Obviously, this is a magnifying glass, or we may call it hand lens. The image is erect, and for all erect image, it must be virtual. The image is magnified, and it must be produced by a convex lens. It belongs to case 6. This is picture B. You can merely see the man inside the lens, inverted. All inverted images are real. And of course, the image is diminished. It is also produced by convex lens, case 2. Picture C. The image is a diminished image, and erect, and all erect images are virtual. And only concave lens may produce erect and diminished image. Picture D. It is an erect image, and all erect images are virtual. It is also a magnified image. Magnified images are only produced by convex lens. This belongs to case 6. Picture E. This is the image. What will you say? Is it erect or inverted? If it is erect, it must be virtual. If it is inverted, it must be real. And how about the magnification? Is it a magnified image or a diminished image? Picture F. Look carefully. Is it erect or inverted image? Is it magnified or diminished? What about picture G? What do you find about the image? Lastly, picture H. You can easily see that it is inverted? Is it magnified or diminished? Check.